SOS, and I'm Jamil.
I'm Najee with New York Giant Pizza.
Keon, it's your boy.
I'm Sheridan. I'm Mike.
I'm Jordan.
Juwan's doing the excellent camera work right now.
Okay, we're gonna do problem 106 from chapter 7, and Jamil and Mike are gonna read the problem for us. We're gonna do part 8.
Alright, so one of the greatest mass extinctions occurred about 65 million years ago, when along with many other life forms, the dinosaurs were extinct. Most geologists and paleontologists agree that this event was caused by a large asteroid that hit the Earth. Scientists estimate that this asteroid was about 10 kilometers in diameter, and it would have been traveling at least as fast as 11 kilometers per second. It's pretty fast. The density of an asteroid material is about 3.5 grams per centimeters cubed on average.
It says A is what would be the approximate mass of the asteroid, assuming it to be spherical.
So it has to be in a sphere.
That's a clue, right?
Dun-dun-dun.
What's the volume of a sphere?
4/3 pi
R cubed.
cubed.
R cubed.
Squared.
Is it squared?
What are we missing from that?
Cube.
R cubed.
Cubed, yeah. It's cubed.
What?
Cubed.
Equals a volume.
Volume. And we're given the density as well, is that correct?
Should we put volume of the sphere or a V sphere?
VOL.
What's the density?
The density is 3.5 grams
Per.
per centimeters cubed.
There you go.
What?
You got it.
She wrote it down.
Alright, so
Alright, what is the question asking?
we gotta find the mass of the asteroid.
Mass of the asteroid. Well, we're given density. We know we can find volume.
So we gotta somehow make the
Cancel it out.
freaking centimeters cubed cancel out, so we're left with grams, you know?
Exactly.
Alright,
Good point.
Thanks.
so we have kilometers and centimeters. So
What do we do,
we're
Mike?
gonna do from there?
So we're gonna
Start with the volume of the sphere.
We're gonna want to find the volume
Okay.
for the sphere. So from the diameter, we could get the radius by dividing it by 2.
So the diameter is 10 kilometers.
We could put kilometers into meters or centimeters.
Exactly.
Okay, centimeters, so divide by 1,000 and then times by 100.
Well, first off, turn it into
Meters.
the radius.
So 1, 2, 3, that's 0.1 meters.
Mm-hmm.
And then to turn it into centimeters, you just go 1, 2. So it's 1 centimeter.
No. You'd be multiplying by 100 and multiplying by
Triple
1,000
zero.
Alright.
because you're going from big units to small units
You
both
just went
times.
backwards.
You're right.
Of course we're right.
Say it again.
Uh-uh. You have to have more.
No.
1, 2. You have to have more centimeters because it's smaller.
Yeah, you're going the wrong
Centimeters
way.
are.
That'd be kilometers.
You're starting with kilometers going into smaller units
Oh,
both
right
times.
here.
The stoichiometry.
You're going from big to small both
Come
times.
on.
Come on. Not a
10
bad
kilometers. Divide by, or times by what? 1,000?
Times it by 1,000.
Times it?
You getting that calculator going, Mike?
Point
Yeah.
zero.
Atta baby.
10
Oh.
kilometers
One.
times 1,000.
It's
Kilometer.
0.01.
Isn't divided by 1,000?
1 million.
You know why? Because we're going from big units all the way down to small
Times
units.
about
And we just take, instead of going one step, we take 2
You're
easy
right,
steps.
you're right.
It's
Gotcha.
gonna be 1 million centimeters.
Hey, look at that, looks pretty.
Times is times 10 to the 6.
What is it, Mike?
You're right.
10 times 1,000 times 100.
It's 1 times 10 to the 6.
Yeah!
That's right, baby.
Is that what that calculator says?
Volume.
Shervin, you concur?
Diameter.
Diameter.
Alright.
Sherman concurs.
Alright guys, so we got the centimeters of
In diameter.
Centimeters.
The diameter in centimeters.
Alright, so what do we do now? We gotta
We need a radius.
cut it in half, right?
Yeah.
500,000.
0.5 times 10 to the 6.
Quick math.
Diameter?
0.5 times 10
That's
to the
Yeah,
radius?
divided by 2 would be
So it's gonna be
500,000.
1,000.
0.5 times 10 to the 6.
5 times 10 to the 5th.
5. Because you're dividing it by 2. You have 1,000,000 right now.
So
So you divide it by 2 to
it's
get
gonna
the
be
radius.
500,000.
Exactly.
Times 10 to what?
So times
5th.
5.
5th.
Exactly.
Atta baby.
Good job, Keith.
Good job.
That was a key play.
Game changing. Pontiac game changing moment.
So we still need
Good point.
to.
Centimeters, definitely
Thank
need
you.
your, definitely need your
Is
units.
it cube?
You're welcome.
Yeah. No, that's just the radius.
Not cubed.
Okay, and we need,
So we're trying
So
to
we gotta
find
plug
the
it in
volume,
now.
so.
Now we
this is
found the
like
radius. Now we can stick it in for R.
It's
So,
like the one.
All right, Mike, bust it out. Calculator.
Plug it in. Plug it in.
So we take. So what we're doing right now is we're sticking in the R value. We're gonna find the volume of the sphere, right?
Correct.
And it's gonna that centimeters with that R cubed right there.
it's gonna cancel out.
It's gonna make it centimeters cubed, right?
Cubed.
And if we have centimeters cubed, then we can cancel out that centimeters cubed and get grams, right?
It's the volume.
Ooh, we're smart. What do you think, Joanne?
It's cubed. We're gonna.
Huh?
what do I think?
What do you think?
I got it, guys.
What
right
is it?
here.
He's got it.
5.23 times 10 to the 17th power.
And is that what you got, Mike?
That's right.
Is
Missy?
that reasonable?
Yes?
Yes, that's
Good
it.
job.
Very
It's
reasonable.
right there.
All right.
You're gonna zoom in.
We got
Right.
precision
Yeah.
and accuracy with our answer.
That's right, baby.
It's
SOS.
reasonable because it has to be really big because we're talking about an asteroid.
A very big asteroid.
They cause a mass extinction.
That did cause mass extinction.
That's
so it has to be
huge.
very
Alright, we're not
big.
done yet, guys. We got the volume. Now we gotta get
That's
the-
part A.
That's part
No, not even.
No, we gotta times it by the density, you
We
know?
gotta
Remember?
exactly in order to get the mass. So we know that density equals mass over volume.
Centimeters.
Actual mass
And units cancel.
extinction.
Multiply your numbers together.
Alright, so I got it right here in this calculator.
That asteroid looks like a shooting star.
So it's gonna be 1.8.
D equals M over V.
No, I'm sorry, 1.83 times 10 to the 18. That's not your density, that's your mass.
What's the math?
Mass equals V times D, guys.
Grams.
There we go.
There it is, part A.
I concur.
How'd you do that? I didn't see it.
So this is the mass of one.
That's good.
So to find that mass, what did we do? This right here,
Divide the volume by the density.
density, and you got grams for your answer. Nice. That's part A. Good job, folks.
Alright guys, so we figured out part A, now it's on to part B, and part B states.
It says how much kinetic energy would the asteroid have delivered to the Earth?
So we're gonna have to use
Energy of motion.
one half the motion equation.
Yeah.
Kinetic energy.
Kinetic
equals
energy. So it's gonna be
1/2 times mv squared.
So this drawing up here is your new diagram, up to date. It's
Yeah,
got
this is a
the values we solved for. Got radius and
this
mass.
is everything we found out so far over here in the
Not
corner.
not good.
Okay. 1/2 mv squared.
Alright, so we know the mass, right?
We just solved
Figured
for
out
it.
in part A, so we plug that in.
K equals 1/2 the mass.
The mass is pretty huge.
There it is right there. There's the mass. Jamil,
The velocity is
Anything
really given
velocity.
to us in the problem, which is
1.3.
11 kilometers per second.
so we can't use that though.
We're gonna have to convert it to meters.
So multiply by 1,000.
Yeah, 11,000.
So it's gonna be 11,000.
There you go.
11,000.
But you have to square it.
Because it's squared.
Can anybody plug it on the calculator?
Got you.
Anybody? Come on.
There he goes. Keone's on it. Hey, Sherman, will you grab this calculator and do the problem too and see if you get the right answer?
Yeah.
You know what I mean?
Get it right.
We got two.
Okay,
Get some
kinetic
precision
energy
going.
is, 1.1 times 10 to the 26.
Joanne's got a calculator on it too, so we've got 3 of them.
Times 10 to the 26.
Can I get that confirmed?
What are they?
I concur.
You got that too?
Yes, sir.
And Sherman, you got it too?
Grams over.
Good job. Good job, Joanne.
What are they gonna
Grams
say?
over meters. Grams times meters over seconds.
Okay, well,
Grams
your
times
mass is in grams, and then
Newtons,
your
joules. It'd be joules.
velocity is
Joules.
It's newtons per million percentage squared, which is joules.
This is Newton.
That's joules.
energy is in
So it's
joules.
joules.
That's what joules are, guys.
So it's
Hey,
gonna
give me your book.
Good call, Sherman. That's joules.
Grams times meters per second is joules.
Therefore,
And it's in the book.
joules,
Yeah.
baby.
Yeah, we have
And Sherman's gonna check it to make sure.
grams times we have meters squared over seconds squared.
Sucho.
Joules.
Exactly.
Shit.
Very nice.
All right, watch out. I'm coming in. We got grams per meters per second.
Now we're gonna, Sherman and Najib are gonna do
Good.
C.
Joules. 1.1 times 10 to 26 joules. That's a lot of energy, guys. Makes sense? That's reasonable, right?
That's right.
If it's supposed to cause this mass extinction, it's gotta create a lot of
That's a lot
energy.
of joules.
It's gotta be a lot.
Alright, and we're gonna know how many joules that are from the next problem.
SOS.
Alrighty, so we're going to do part C, and from the previous problem, we got that the kinetic energy equals 1.1 times 10 to the 26 joules. So now Keely's going to read part C for us, and from there we're going to solve the problem.
Alright, it says in order to put the amount energy found in part B in perspective, consider the following. One of the largest nuclear weapons ever tested by the U.S., the Castle Bravo bomb, was a 15 megaton bomb, meaning that it released the energy of 15 million tons of TNT.
Wowzers.
1 ton of TNT releases 4.184 times 10 to the 9th joules. How many Castle Bravo bombs
That's a
would it
lot.
take to produce the kinetic energy of asteroids that did in the dinosaurs?
Alrighty, so we know that the TNT has 4.184 times 10 to the 9 joules of energy,
Right.
and from there, we know that the Castle Bravo bomb has 15 million.
Get that?
So, in order to find out how many of the Castle Bravo bombs we need, we're going to compare it to the kinetic energy of the asteroid. So, we have 1.1 times 10 to the 26 divided by these two numbers multiplied because that's one Castle Bravo bomb.
Alright.
So, can we do it
Are you
on
guys gonna do that on the calculator?
Yeah, we're gonna do it right now.
this divided by this? So, it's the kinetic energy divided by those two,
Okay, there we go.
right?
So let's all do it real quick. 4.185,
Times 10 to the 9.
19, 9.
To the 6.
No, times 9 times to 1 to 15 million. 1.5 times 10 to the 6.
Good call, Sherman.
So then you would take the 1.1 times
This equals
0.6.
6.2775 times 10 to the 15th.
Is that right? Is that what you guys got?
So then, so just to make sure I understand that, right, guys?
One Castle Bravo bomb.
Exactly.
So then, just to make sure I understand, you want to take the kinetic energy we found from part B
One new.
and divide it by the 6.2775 times 10 to the 15th.
Exactly. In order to find out how many of these bombs we need.
Alrighty.
So this is over.
That's
No,
only
this
for
is
one.
over that.
That's only for one,
For
Oh,
how many
for one.
Castle Bravo bombs?
and then they
Yeah.
have 15.
So it's
Okay.
only for one.
Alright, so we got this, so you divide this number here,
By
1.1 times 10 to the 26 joules.
You should get a really big
So,
number, shouldn't you?
asteroid. Am I right or no?
Yeah.
Yeah.
Okay. Asteroid,
And then
bomb. And this equals, and this you're gonna get a ratio, right?
Yeah.
Is that what it is?
How many
asteroids?
how many of these
Bombs.
need to be
For a bomb?
an
And it
asteroid?
should be a big number,
Your
right?
answer is going to be 1.75 times 10 to the 10th power.
Let me see if I got the same answer.
What?
I got that.
Did anybody else?
Let's
You
do it
guys
first.
have
This is
that?
huge
Everybody
number.
concurs that that is the right answer?
Confirm.
What'd you get?
1.75 times
1.75 is what I got. Times 10
to the 10th.
to the 10th. That's a huge number.
So that's how many of these nukes.
Castle Bravo bombs.
Okay, nukes. That's how many nukes in one asteroid. One asteroid.
And that's how many we think because
Think.
we've never actually had, using nukes in order to destroy the Earth. That's just how many we think. It could be less, but we know it's not going to be more because we've had that much energy destroy the Earth
It's
before.
reasonable.
So you don't know the exact number, but it's an estimate. It's
Yeah.
around that number.
Yeah.
It could be smaller, but it can't be any bigger.
That's true.
But it's still a really big number.
Why not?
That's a lot of bombs.
What was that?
Why not? Why can't?
Well, the reason it can't be bigger because we've already had this happen before. That's the minimum we know, that amount of energy that will destroy the Earth. But we've never tried nukes, so it could be less. But this is
We know this works for sure. Anyways, that's what the theory is. We don't know if less energy could have destroyed the Earth, but we know that a minimum of
as
this
a
will
bird
destroy the
already.
Earth.
Exactly.
Hey, why don't we call North Korea and have them use a couple of their nukes?
Yeah,
Good test.
the good thing is there won't be a mass extinction, I guess, from that's a lot of nukes. I don't think there's that many nukes in the world, but
Okay.
Hopefully.
nuclear holocaust is another story though too.
So our answer is reasonable.
It is reasonable.
Very reasonable,
Okay.
yes.
It's huge.
Alright,
So is
is
SOS.
that the whole problem?
And so what they did do is they tried to find a hole big enough to prove that. And that's what we talked about with Tony before.
That's right.
Alright,
Yeah.
there's,
So that is the problem.
That's the problem. That's our answer. It's reasonable. We reference it kind of to what a nuclear weapon can do, or a lot of them. And it makes good sense.
We combined as a group. We found an answer. It's SOS.
and it relates to real life.
And it relates to real life.
Okay, so that was
No
our,
more nuclear weapons.
that was our session,
Oh, one more thing, John.
yeah.
Right here, get that number down. Who is it? 326 NY.
Best pizza
Best
around.
pizza in town from New York.
Just because you don't have any business, doesn't mean you promote through your physics class.
Hey,
Alright.
hey.
Good stuff.
Alright, this is,
Late.
Mike,
Uh,
It's your boy Jay.
later.
alright, bye.
Bye.